This is another Mohr circle example. It's problem 916 from the Pearson book. You can see this stress element there. We have the 50 megapascals in the x direction. We have 15 megapascals for the shear stress. And it's on the x face, at least it's going in the negative direction or in the clockwise direction. They want us to find the principal stresses and the principal stress angle. And so those are stress 1, stress 2, and theta p. And then they also want us to find the maximum in-plane stress and maximum shear stress angle, which would be tau max in-plane and the theta s. And so to solve this, we'll want to draw a Mohr circle. We can start by writing out the x face and the y face. And remember, the x face is the stress in the x direction, so that's 50 megapascals. And then it's the tau, which is in the negative direction because it's moving clockwise. So negative 15. And the way we get that direction is pointed in this direction. And that's in a clockwise direction, which would make it a negative number. Or you can use the right-hand rule to get the negative number there. And then the y face, the stress in the y direction is 0, and then the stress in the x direction is 15. And so with that one, we can just do the same. So we look at this y face here. It's moving in the counterclockwise direction, which means that it's in the positive direction, or what we call positive. So now we'll just draw our Mohr circle. Let's see, I'll draw it here. We know it's sort of off to the right. We have the stress in this direction. We have positive tau pointed down. Um, our x space is 50, negative 15. So uh, our 50, do 50 here, and then negative 15. So do it to here. That's the x face. And then the y face is 0, and it's positive 15. So 5, 10, 15. That's the y face. Then we can draw our circle around those 2 points. So now we have our circle. We can draw a line between the 2 points. This, the center point is going to be our average stress. Um, and the stress average would be, so it's between 50 and 0, so that would just be 25 megapascals. So we have the average stress. We need to find those principal stresses. So we need to find what that radius is. Let's use a different color. So the R here, we know this bottom piece is 50, and then this here is 15. So R is just going to equal the square root of 50 squared plus 15 squared. And the answer for that, probably my calculator. Oh, I lied. Let's see, there's a mistake here. See if you can see it. I just saw it. So this distance right here, the whole distance from the y-axis to there is 50. This distance here would be 25. Glad I caught that. So 25 squared plus 15 squared, or the square root of that, gives us 29.15. That's megapascals also. And so now we know that. So now we can find that stress 1, it will be right here, all the way to the right. The stress 1, and stress 2 is all the way to the left. So now we can find those. I'm gonna move down the page. But so stress 1 is going to equal, so the distance between here and here is also 25. So it'd be 25 plus 29.15. So that gives us 54.15 megapascals. Is for stress 1. Stress 2 is going to be basically that 20, if we go from the center point, we know it's going to be 29.15 megapascals to the left of that. So it's going to be 25 minus that 29.15 megapascals. So that's negative 4.15 megapascals. So those are the two of the things that we needed to find. So stress 2, stress 1. And now we need to know that angle to that, pick a different color, but the angle to those principal stresses. And so that angle is going to be here. And we're going to call it phi because we're in the Mohr circle. So phi 1. And that's just going to be, or tangent of phi 1 would be opposite over adjacent. So 15 over 25. And so I just moved it to where phi 1 equals the inverse tangent of 15 over 25. So I'm going to do that on my calculator. 30.96. And it's in the negative direction, right? So negative 30.96 degrees. So what would I guess that would actually be P1. And then we want to translate that to theta, to the real world. Theta P1 is going to equal the phi divided by 2. So that gives us 15.48 degrees. And I guess we actually, because they asked us to find principal stress, it's supposed to be the principal stress angles. So that would be the stress P1 or the theta P1 and theta P2. So theta P2 is just going to be this angle here. So it would be from this, or sorry, from this one all the way over to there. That would be that theta, or phi P2. So phi P2 is going to equal 180 minus that 30.96 degrees. And that's going in the positive direction. So we get 149.04. And then we need to move that into the real world. So change it to the theta. So divide it by 2. Gives us 74.52 degrees. So we have all those that we needed. So this and this. So that was the first part of the problem. The second part is we wanted to find the maximum in-plane shear stress. And so that is, oh, I like a different color. I'll do that one. So that would be down here. Oh, that was the wrong. So that's the max in plane. And we know that radius, so it's just going to be, it's down in that positive direction of that radius. So tau max in plane is going to equal 29.15. And so we have that, and now we need to also find that angle for the shear stress. Um, and it's basically going to be this angle here. So the angle going over to where that X face is. So that would be phi of the S1. And then phi of S2 would be this angle over here. So phi S1 is going to equal, it's basically just 90 degrees plus that here. This is 90 degrees here, and then plus this angle. So phi P1. So it's just going to be 90 plus phi P1. So that's going to equal 120.96 degrees. And then we'll take that into the real world. So that's just going to be divided by 2. 60.48. And then the phi S2 is just that the phi S2 is over here. It would basically be that let's see, it would be the easiest way to do this. So it'd be 180 minus that phi S1. So 180 minus that 120, 120.96. So that gives us 59.04. And theta S2 is going to equal that divided by 2. 29.52 degrees. So I was basically just drew it out on the Mohr circle and then figured out what would make sense. So this one it was just a 90-degree angle plus that phi P1, and then phi S2 is, I just took the whole 180 degrees minus that phi S1 would give us the phi S2. So you can just figure it out by looking at it. And so I think that was everything that we needed to find. Let's go ahead and draw it also. Yeah, so I'm going to highlight them. That one. Oh, let's see. This one and then this one. So let's go ahead and draw it for the maximum in plane stress. Yeah, I guess I should have done the other one earlier, but this is fine. We'll do the maximum in plane first. We have our, where it was before was like this, and that was off to the X. We know it's 29.52 degrees. I guess it'd be less than that, something like that. That's where this will be pointed off of. And then the stresses, they're going to be the stress averages, which are 25 megapascals. And then the shear stress, or the maximum shear in plane, is this one, and it's 29.15. And then just to show why that's the average, so the maximum in plane is down here at this bottom point. Oops, down at the bottom point, and that's at the where stress average is. And so that's why that looks like that one. And then for the other one, the we had stress one was 54.15 megapascals. And stress two is negative 4.15 megapascals. And the theta P1 um, was um, in the negative. It was in the negative direction. Capture that. It should have been, yeah, it was negative above, so I just didn't capture here. So it's negative 15.48. Um, so I'll just rewrite those really quick. 54.15. Stress 2 was negative 4.15. Those are megapascals. And then theta P1 equaled negative 15.48 degrees. And so we're going to start with that stress is going to go. So it was, when it was arranged the way it was initially, it was straight off to the right. And so we're going to go down 15.48 degrees. And then that's where how it's going to be oriented. Um, and so that one was the 54.15 megapascals. Stress 2 is in compression, so that's 4.15 megapascals pointed inwards. And then we don't have any shear stresses at those points. And you can see that in the Mohr circle. So at the Mohr circle were the stress ones, so it was these pink ones here, or we'll do this here and here. They're along this, and so it's where tau equals 0. And that's it.